2048 is a puzzle game where players slide numbered tiles into each other to create a tile with the value 2048. The lowest possible tile value is 2, and the merging of two tiles results in combining their values, which can only happen when their values are equal. The game was super popular for a brief period in 2014, and as far as I'm concerned, was kind of the beginning of the merged madness that has become a huge market in mobile and web games. As it happens, this game was originally released as free and open source software, so it feels doubly appropriate to recreate it in Raylib, being free and open source itself. At the start of this project, I already have some code prepared. We have a grid struct and some related functions for drawing the grid, as well as getting the position and size of particular cells in the grid, which we'll find very helpful in drawing the game's tiles. We can see I have just a few constants, and that the main file is very small. The idea here is that if there's any window management or app lifetime scope that needs to happen, we can put it here, separate from the game's logic. The game.c is quite a handful. We have an enum to track the game state, with matching functions for each enum value. There's a field for the current state, and another for the grid object. In the begin game function, to be called when leaving the start or lose screens, we initialize the grid based on the game's rules and update that state value. The draw game function is the one called from main in the update loop, so we switch on the state value and call the appropriate draw and update function. For now, draw gameplay simply draws the grid we prepared in begin game, but this is where we'll be writing our game's logic. The draw start screen and draw lose screen functions are very similar to one another. Their function is simply to display a message to the player and check for input to start or restart the game. All of this code is pretty straightforward and has very little to do with the game we'll be writing today, but if you have any questions about it, don't be afraid to ask in a comment below. The first thing I want to do is try out those grid cell size and grid cell position functions. So we need to create an array to represent the spaces in the grid and write some logic to draw tiles according to the values in that array. I chose to go with the 2D array here. If you haven't seen one of these before and are looking for another example, I also used one in my Raylib Minesweeper video. The idea is you essentially have an array of arrays, which forms a kind of grid. The first index in this case will represent the column, and the second will represent the rows. This makes it convenient to use X for the first index and Y for the second, which will be easy to visualize. In order to focus on drawing the cells and getting the basic mechanics of the pieces sliding around on the board, I'll just write the pieces array to use the color type provided by Raylib. Given that blank is the given name for a color with 0 for the RGB and alpha values, we'll use that as our default or empty value. I'll write a function dedicated to drawing any existing pieces, which uses a pair of for loops to iterate over all the columns and rows of the grid. I'll run into a problem where I try to compare the value of pieces at a particular coordinate with the named color blank. I'll run into a problem when I try to compare the value of pieces at a particular coordinate with the named color blank. Since C does not have any method for comparing two structs even of the same type, we'll write a quick utility that compares each of the individual character values. In other languages, we may override an operator or provide some kind of comparator method. The idea here is that if a particular element of the pieces array is blank, we can just skip that element altogether. I've heard this approach referred to as early out or guard clauses, and the main benefit for me is to reduce code indentation, since having multiple if statements can cause the code to drift to the right. So in the cases where we get past that statement, we actually want to draw a tile. I'll use the vector variant of the draw rectangle function and simply pass the grid object and the XY coordinate of the current tile through to the grid cell position and grid cell size functions, and use the result of each to draw the tiles accordingly. Since the grid is uniform, the cells are the same size, and we can cache the result of that function and do considerably fewer calculations when drawing these cells. To test our draw cells function, I'll force specific values in pieces to have visually distinct colors and build the game. I'm doing this just to check that the pieces are in the spaces I expect and at the size that I expect. The grid alignment isn't perfect, but that has more to do with the way I chose to draw the inner grid lines than it does with the code I've written to display the cells. Next, I want the pieces to move when I press the arrow keys. To get the basic idea going, I'll write logic that snaps the piece to the edge of the grid based on the direction pressed. The first step is to capture the direction of my input for the current frame, which I can do very quickly by abusing the fact that bools in C are simply 0 and 1 integer values. By setting the X value to right pressed minus left pressed, I'll have positive 1 for right, negative 1 for left, and 0 for when neither is pressed. The idea here is that if I'm pressing right, then X will be positive, and that is the direction I want the piece to move. I want it to move positive in the X direction. I'll write the logic for moving the pieces right, and then we'll duplicate it for each of the other three directions. Copy the value of the piece you want to move, set the piece's original position to blank, then put the copied value into whatever the piece's final position should be. It's just like a swap. I'll need to be careful to update what I'm setting the x and y values to for each of the edge positions based on the direction we're moving the pieces. For the right and bottom edge, it's the number of columns or rows minus 1 respectively, and for the left and top edges, it's simply 0. Once they're all working, we can see we can collapse all the pieces into a single space. Of course, this is not how 2048 works. We need the pieces to stop each other when moving. So let's look at how we might do that. If we're going to be considering other pieces, we need to take special care in the order we check the pieces in. Since we're moving the pieces to the right, we need to check the pieces from right to left. If I check left to right and any rows have more than one piece, then I'll need to press right multiple times to move all the pieces to the right. Moving pieces down, I'll have the same problem. I'll want to check the lower rows before I check the higher rows. In order to consider other pieces, I'm going to take the approach of having a candidate index, which I repeatedly advance and check if it's still valid. This type of approach is easily served with a while loop, and this is more or less how it's written. Take special care to use a known safe index as the first candidate value, since the idea is, by the time we pass the while loop, the index should be the result of the move. If we start with new x equals x plus 1 here, for instance, and we're moving the rightmost piece, we could accidentally index out of the array and have a pretty nasty error. The while condition guards against us running past the edge of the grid, but notice that we use less than columns minus 1. Normally, if you want to address all columns, you would use less than columns. The minus 1 is here since we want to check not only the value at column new x, but we also want to check the value at column new x plus 1. And if we allowed new x to reach columns minus 1, then we would have new x equals columns minus 1 plus 1, which is columns, and we still have that array overflow. We also have a break check for the while loop to make sure that the tile to the right is empty, and if it's not, we break. After another quick build and test, we can see that the pieces no longer overwrite each other while moving right. Of course, this still needs to be propagated to the other 3 directions, but first I just wanted to quickly show what would have happened if I didn't change the order we move the pieces in. So I said we have to move right to left. Let's try left to right. The blue tries to move, sees the green is in the way, so it fails to move. Then the green moves, and now we have to press right again so that the blue can now move because the green originally was in its way. Now it's time to update the other 3 directions. It's not clear whether I screwed this up while I was demoing why we needed to go right to left, or if it was just one of these mistakes when copy-pasting code, like I said, can happen, but there was a couple cases where the pieces weren't colliding just right, and this took me several minutes. As I said earlier, code duplication can be a serious problem for maintainability and readability, and is also extremely error-prone. Once the pieces are being properly stopped by each other, it's time to make the switch from basic colors to values. I'll create an enum to easily manage the names of the values as well as a function to return the desired color based on the value. Then we can update all the places in the code where we refer to a piece by its color to now use piece value, and remove all uses of that color equal function. I forgot to include an enum value for blank pieces at first, so I added that in and tried to use it to initialize the 2D array, but it just made a crazy bug where the board was full of pieces except for one slot. At this point, I decided to just use memset to fill the 2D array with the value -1. The color is a nice touch, but it's not the whole story. We need to display the value of the piece on the piece itself, so we'll need to use draw text as well as a new function which can switch on the piece value and return a string literal for the number. Before we spend any more time on appearance, I want to make another gameplay change. We need like pieces to merge when they slide into each other. In our while loop where we decide if the space the piece is headed for is valid, we're going to add an extra check. If the space is not empty, but it has a piece with the same value as the piece which is moving, we can merge them. I'll set the piece that we're hitting to have a value of none, and increment the moving piece's value. As we've done several times now, we propagate this change to the other 3 cases and see what effect it's had. After my test, I noticed that it's not functioning exactly how I'd like. I'd prefer if the 2 2s combined into a 4, and then in a separate move I would merge the 2 4s into an 8. I can change this very simply by updating the code to increment the piece I'm hitting and destroy the moving piece instead of the other way around. Next, it's time to add logic to spawn new pieces in the board, which we'll ultimately call each time at least one piece moves. My idea here is to pick a random space on the board and repeatedly advance until I hit an empty space, at which point I can use getRandomValue to most often choose a 2 but occasionally choose a 4. I'm not certain that this is a classic 2048 thing, but the version I used to play did something like this, and if nothing else it adds an extra pinch of random. A combination of integer mod and division are used to convert the 1D index of 0 to 15 into valid coordinates for the grid. An important note here is the for loop doesn't go from 0 to 16, but rather it starts at whatever the randomly chosen first index is and can wrap from the end of the board to the beginning. After 16 checks, we've wrapped all the way around the board, and thus the board is full, and we would have an error case since we shouldn't be calling this function with a full board anyway. For now, I'm calling this a lost state, but we'll adjust it later since this is technically not a lose condition. Now we can remove our two hard-coded values for the first two pieces and use the add piece function instead. Since we only want to spawn new pieces when at least one piece has successfully moved, we will add some logic to pieces move to track whether a piece moved and return it at the end. For that, I'll just check before we update the piece values that the new x does not equal x in the horizontal cases, and the same for new y and y in the vertical cases. Of course, that bool means nothing if I don't actually check the result in the game loop and use it, so we'll update that quickly as well. It looks like we have the bulk of the game's rules now, but it also looks like it could be broken and we wouldn't know. A big part of this is because the pieces don't animate between their positions. They kind of just pop in either from being spawned or they move from their original position to their new position instantly. What I need to do is evolve the pieces array one last time from using a piece value to a piece struct that I write, which can track some much needed metadata for the animations. We'll need to update all references to the array to access a member of the piece in the array, instead of accessing the value directly. If I was smarter, I would have started with the piece struct. That way I wouldn't have had to rewrite all the uses so many times, first when going from color to the enum, and now from going enum to the struct. I also had to rewrite the memset I made earlier to work properly for the struct. I think it could have been easily done, but I just got fed up and I wanted to get forward with the video, so I just went back to a double loop and deliberately set in each value an empty piece. My idea for the animation is to set the start and end point of the animation every time we decide to move a piece. It's when I set the start and end positions for the animation that I'll also set the duration of the animation, which I'll just use a defined constant for. What this means, though, is that regardless of whether a piece is moving one tile or three, it'll take the same amount of time, which has a cheap-looking visual, but that's a discount that I'm willing to accept for the simplicity it brings on the input locking side of the code. Once I've updated all the areas where we set a piece's new position, we need to update the logic for drawing a piece to use the tweened position as opposed to the grid position given by the piece's coordinates. Instead of setting the position directly to the result, we can use lerp from Raymath to interpolate from the start to the end position, and just use the grid position when the animation is finished. In testing, I noticed that the pieces are only animating when a merge happens, which means my logic to set the animation data was not being hit in cases where we don't merge. With the little tweens, the piece movement looks a lot better, though we do still have some pop-in from the pieces which have just spawned. Now I'll add an isSpawning bool and a piece create function that we can use whenever we create a new piece, and I'll update the draw logic to allow for a fade-in animation. At this point, I think it's time to start tying up some loose ends. I think we're getting towards the end of the video here. I'll start with the lose condition. Each time we spawn a new piece, we have to check if there's any possible moves for the player to make, and if there isn't, then we can show the lose screen. For this, we'll iterate through every position and check if the piece to the right and below have the same value, and if at any point we get a match, we can have an early out. But if we go through the whole grid and there's no matches, then we should fail the player. Of course, there's some exceptions here. For one, we don't want to check the pieces to the right when we're at the right edge, and the same goes for the bottom at the bottom edge. Also, it's not just that there needs to be a match along those axes. It would be enough for there to be at least a single empty tile anywhere on the board. In practice, it feels very jarring for the game to so suddenly end, and I recall in the version that I used to play that there was a couple seconds before it faded to the lose screen, so I'd like to implement something like that. The idea is to make use of a timer and a full screen white rectangle, which can fade in before the state change, and then fade out to reveal the new state. More specifically, we need a target state and a state timer. I'll add a draw rectangle call to the end of each of the game states. Originally, I wanted to draw this only from draw game, but I made the foolish decision of combining the update and draw into one function. I can't easily have an overlay for all states, so more copy pasta coming. Something in the lose logic is a little broken, but at least the fades are looking pretty nice. Okay, yeah, that time the game thought I lost, but I clearly was still able to do some input. So I want to lock input when there's a state transition. And of course, I also want to make sure that the game only says we've lost when we've actually lost. I'm going to add a delay before the fade starts, since apparently I can't make my mind up about whether or not I ever want to finish this video. The approach is the same as the state transition. Add a timer we tick before we begin the first fade. When it ends, then we can trigger the normal state change logic from there. Now when we lose, we get a chance to actually realize that we lost before the game tells us. It also makes it easier to spot what was actually wrong with the loss detection logic, so maybe I should have done this earlier. I'm also going to make some small improvement to the loss screen here, showing what the highest piece the player achieved was. I think feels like a good sort of consolation prize. The easiest way to do this is to loop over all the pieces at the end of the game and just pick the max value as we go. Now we can update the lose screen to include this new information, and as always, give it a quick test. Okay, now we have a lose screen. We haven't fixed the checking for an empty space yet, but I'll add that later. But we don't have a way to win. So even if I do reach to 2048, I don't win. And I'm sure that there are versions where you can just keep playing after 2048, but my objective here is that you hit 2048 and the game ends. Maybe it'll say how long it took you as well. Okay, it's finally time to address the input and false fail issues. For the input, I'll write a function called input locked, which simply returns true when we shouldn't take input, and add it in all the places where we directly take user input. The return value of this function simply reports whether one of the timers are active, and if so, no input. In check for lose state, I'll add a check if the current piece is none, and if it is, we can immediately return. And with that, I believe we've done it. I didn't make this because I think 2048 is a fun game. I also didn't necessarily make it because I think it's historically important, although maybe it is, especially with the context at the beginning about merge games. But the main reason I made it is because I thought it would be funny to have a themed subscriber milestone video. Now at this point, it's already considerably late, and that's too bad. I waited too long to make it, and then when I did make it, I had a bunch of problems, and I just wasn't happy with the video. Hopefully you learned something. Hopefully you thought it was interesting. Originally, I wanted to have this end with showing how to port it to the web, but it just, again, lots of issues came from that. And I'm kind of glad that I didn't, because it looks like the latest version of Raylib is going to actually have some one-click web deployment, which is very interesting. So look forward to a video on that subject once that's released. This is the most fun part of making these videos. I'm declaring it done, I'm putting it out into the world, and it won't be long before the comments roll in asking me why I did certain things or pointing out mistakes. I love those comments. It's a good learning opportunity for others, and of course it helps me a lot. So please, if you notice anything funny in this video, leave a comment below. I will pin or heart the first report of each issue. I'm not a master Easter egg artist. I didn't deliberately do anything wrong for this video. It's just been really rough. It's been a while since I made a video. Thanks to everyone who has followed me so far and has decided to subscribe to the channel. Hopefully you enjoyed this, and hopefully I'll see you next week for a new video on Raylib workflows.